separate. So we have to count out one-to-one correspondences between two sets. And then we have a couple questions about 9. So a one-to-one correspondence is where we try to match every element in one set with an element in another set. So one possible way to do that is the obvious way, in order. So I would take set A, capital A, which is little a, little b, c, d, and e. And what I want to do is pair A up with something in set B. So I could pair A up with exclamation point, and then I could pair B up with the @ symbol. And then I could pair C up with the hashtag. And I could pair D up with the $, and I could pair E up with the % symbol. So this is an example of a one-to-one correspondence. Now, there's lots of other ways I could have done this. There's no reason A had to go to the exclamation point. I could have paired up A with the @ sign instead. Ooh, that's not very good, @ sign. And I could have put B with the exclamation point, and I could have put C, yeah, let's leave C with the hashtag. And D, yeah, you could stay with the $, and E could go to the % sign. So this is a different example of a one-to-one correspondence. And we could do this all day long. Well, not all day, but we could do it for about 20 minutes. So a one-to-one correspondence exists when the two sets have the same cardinality, so that every element in one set has a partner in the other set, nothing gets double counted, and we don't miss anything. So let's break it down another way. So starting with set A, B, C, D, and E, how many choices do I have to pick a partner for A? Anyone? 5, says Jimmy. Yeah, there are 5 choices to pair up A with something, right? So let's say I do it. I'm going to pair A with the exclamation point. So A is now done. A choice has been made. Then I move on to B, right? A is already married to the exclamation point. How many choices do I have for B? 4. Yeah, and it just keeps moving down the line. B has 4 choices. And then C, because A and B are married, right? There's 3 choices left for C. There's 2 choices for D. And once I've married A, B, C, and D, E is stuck with whoever is left. And it turns out when you have these discrete choices like this, you can just multiply them together, and that gives you all possible outcomes. So 5 times 4 times 3 times 2 times 1. So what does that give us? 5 times 2 is 10. 4 times 3 is 12. 10 times 12 is, there should be 120 different one-to-one correspondences. I'm going to write that where I have some space. So this would be my answer for part A, like right there. I'm going to put my answer to part B right here. There are 120 different ways to correspond elements in set A, with elements in set B. And then below is my evidence of that. So my answer is just this right here. And this is my work as to how I got that. All right, one-to-one correspondences. And then this idea of multiplying choices is called the fundamental principle of counting. And let's take a look at